Come now. Yeah, welcome to Introduction to Gemini, part of the Google developer community on Discord, Build with AI sessions. So today we are going to dive into Introduction to Gemini. We'll talk about what Gemini is, what led to Gemini, what brought about Gemini, what are the tools that influences Gemini, and what are the superpowers of Gemini, and how can you use Gemini to improve your product day to day. Yeah, so what is generative AI? So like I said in the description to the Gen AI is just it's a budding word, it's a buzzword whereby it's just what is happening at the moment. People are just talking about it. So I would do an intro to Gen AI, and I'm also going to give sort of a definition of generative AI. So we can see generative AI as a fascinating field that is at the intersection of AI and creativity. So it typically revolves around the creation of machines that can generate content autonomously, offering, mimicking, or even surpassing human-like creativity. So that's an high-level overview of what Gemini is. It's a subset of AI techniques that enable computers to produce new, original content autonomously. And this content can range from images and music to text and even narrative. So what's an LLM? An LLM is a neural network that models the distribution of the text on which it is trained. So LLMs stand for large language models. So it can take an input like it is raining cats and complete it with it is raining cat and dogs. So something like that. That's a large language model. So and it's able to give the next word based on what it has in its training data. So some people can see an LLM model as a sophisticated autocomplete model, something like that, as a basic definition. So something like this, when we have roses are red, it's the LLM can typically detect that you are about to write a poem, and it can fill it up for you. Or roses are red, violet are blue, sugar is sweet, something like that. So LLM is able to complete your thoughts based on the training data that it has inbuilt with it. So, and if you are also writing something technical, and LLM model is able to also do an autocomplete for you when you're writing a code text. So if you are someone who is familiar with GitHub Copilot, you would know that all these things are really happening. So when you want to type for a variable I equals, can similarly generate a completed text for you, which is something like this in JavaScript. And what this is just saying that it is going to execute a for loop, and it's going to execute a for loop for the code 10 times, starting with I equals to 0, and it's going to increment it by 1 after each iteration until it reaches equals to 10. So LLM models are able to do this. So what's modern LLMs? So they are pretty very large. So we know that the current generation of large language models are trained on large, diverse data sets that represent all kinds of languages and context from around the web. So these models typically have like billions, sometimes even trillions of parameters. So they capture language structure more complex than we have seen in previous generations, like your phone's autocomplete. So the current LLM models, they are pretty large, and they are able to use a whole lot of parameters, and they can do things at a faster rate than what previous generations models have been doing, what previous AI breakthroughs have been doing. And that is what LLM is really special, and it's erupting the current technological space. So what are the classical natural language problems that we have? So we've bragged about how LLM are super fast, super interesting, can do a lot of fascinating things. So all these things that I can do, they make them useful for common natural language problem that we typically have to train different tasks to work on them, like entity extraction, classification, summarization, sentiment analysis, translation, and etc. You can give an LLM a piece of text and ask him to determine the sentiment of that particular text. You can throw an image to it. It can bring out the sentiment from that particular image. It can extract entities from different things, and it can also like help classify summarize. So that's some interesting thing about LLMs. So LLMs let us prototype pretty fast. So one of the top abilities of LLM is that it can prototype AI-driven application really fast. So it can let us prototype AI-driven application at an insane speed. Because we know that traditionally, when you're building an LL and a machine learning powered app, you would typically collect thousands of examples from your domain. You train your model. You're also going to tune your model, which means that you're like customizing that model to a particular result. So before you can now start evaluating or even explore the suitability of that particular model, before you can explore if the model actually works for what you are doing. So we all know that this takes a whole lot of time, resources. But now with LLMs, you can explore an AI-powered idea in minutes, and you don't necessarily need so much of machine learning expertise, possibly as we would see at the tail end of this call. So thanks to this really impressive beauty of LLMs, LLMs are also able to perform well on a new class of human language tasks like explaining humor. So if you'd see in the example used here, so I used to be addicted to soap, but I'm clean now. So the LLM is able to understand that this is a joke. It does not just take the literal meaning of soap as to clean something. It's able to understand that this could mean maybe I am addicted and I'm free of addiction from anything. It seems like an idiom, something like that. It's able to understand joke and humor, and also able to explain it to a user or to the prompter. So, or something like this. LLMs are able to give us responses for stuff that we want. Give me 5 neat ideas for a science fair project. It's able to offer some ideas like build a volcano, make a solar bone, create a 3D printer, build a robot, or design a water filtration system. If you enter that command on your own LLM model, it's also able to return a result suitable to your questions. So it's able to be very creative, and it can also help in different prompting responses. So what are the large language models? So why are they different? Why are they really different? So we know that LLMs have emerging abilities, which means that they do not have to be explicitly trained to do things. So you can just train them on a large corpus of text, like a large variety of text, and it learns to translate answers. So it can now learn to translate. It can learn to answer questions. It can learn to generate code and so on, just based on the explicit things that you've trained it on. So it's not that you are training it for each specific thing at a particular time. So it's able to learn from the different data set that has been exposed to it, and it can now solve a particular user problem at a given time. So another reason is LLMs changes how we interact with intelligent system because of their contextual understanding of human language. So you can, instead of writing it in a codified format, you can write it in just a natural language, and it's able to translate what you're inputting to code, and input those code in its application. So with an LLM, an SQL query can just be a simple question. You can just ask the LLM to generate a query to display the top 10 users in different regions. It's going to come up with a query in a blink of an eye. So you can also use it to find information on a website. So another benefit of LLMs is that they are the next in Google's machine learning journey, and they are the next thing. Typically, any big company machine learning journey. So many years ago, we are like using everybody was using regression, classification, clustering, but now with neural networks, we are now able to unlock hidden patterns in a much larger data set. So it's more than just forecasting. It's more than just regression. It's more than just pretty much statistical analysis. Now with LLM, we can unlock hidden patterns. We can find patterns and connection in massive and dispersed data sets. Okay, so that's about that. And this is just typically Google's journey in AI. So going from typically when they started, which is more often than not when they really pushed their first AI model to the public, which was 2015 when they pushed the Google DeepMind AlphaGo, and the the model was able to defeat a current Go champion at that particular time. So going to 2016, the DeepMind project helped detect eye disease. 2017, they invented Transformer kickstarting LLM model. So most LLM models are built off Transformer. So the model the underlying model that powers most LLM model here is a Transformer model. So this Transformer model is like the pioneer moment. It's like the pivotal moment of the current LLM journey. So moving to 2018, a groundbreaking large language model, which was BERT. Then 2019, text-to-text transfer using the Transformer large language model, and they also open sourced it. 2020, the Google Lambda model, which was trained to converse. 2022, AlphaFold, which predicted structures of all known proteins. 2023, we had the conversational AI service powered by PAM2. So during all these things, we're already seeing that the importance of LLMs. We're seeing the beauty of what LLM could do. And now 2024, we are now in a multimodal LLM and product, which is Gemini, and Gemini is the current largest Google AI model. So the multimodality of Gemini, we'll talk about that in a bit. But before that, it's always good to be focused on the responsible part of AI, whereby it is built for safety. It is built for safety. It also upload scientific standard. It is socially beneficial. It inculcates privacy in its design. It is also accountable to people and can also avoid creating unfair bias. So all these are things that you as a user and also top contributors to AI like Google, Microsoft, other companies, OpenAI, they should also like inculcate in building their AI. They should be responsible by design, and they should also be and we should also be responsible in the usage of artificial intelligence. So you can see from all this that generative AI it's really part of Google's DNA, and it's something that influences a whole lot of things that they are doing and a whole lot of products that they are pushing in out. So going to multimodality. So what's multimodality? And you can even ask that why is it important? So if I would just explain the definition of multimodality, and I think when we are clear on the explanation, we can typically understand how multimodality helps us. So multimodality just refers to the ability of a system to process and understand information from multiple modalities. So these modalities can be text, can be images, can be audios, can be videos, can be sensors, data, and etc. So just like the human brain or the human body can seamlessly integrate information from our senses to understand the world. While my eyes is seeing something, I can also be touching something. I can also listen to what's going on, and I can use that to influence or integrate multiple information to understand what's going on at that particular time. So at the moment, also multimodal AIs helps to achieve something similar to that level of understanding. If you are just giving it text, so there can be a loss of emotion in between text. So when you just read text, and compared to having a text and an audio format, when someone is crying, it's not going to show in the text unless the person indicates that is crying at that particular time. But using multimodality, the machine learning model, the AI model, is able to integrate different type of inputs like text, like images, like audios, and it's able to use that to influence the responses that it gives. So there's text, there's audios, there's images, there's even videos. So those input sequences can be passed into the transformer model to either give us a image response or a text response. So that's the idea about multimodality. So which really brings us to our topic for today, which is Gemini. So we are in the Gemini era, and Gemini is here to stay. So I foresee Google iterating on the Gemini model and also developing it to become more fantastic and more stable. So Gemini is built for modality. So it's built to sustain modality, to accept modality, which typically means it can reason seamlessly across text, across images, across audio, and across also code to formulate a response. So there are three Gemini sizes. We have the Ultra Gemini, which is the Ultra model, which is like the most capable and largest model for more complex AI tasks. Then we have the Pro model. So this model is the best model for scaling across a wide range of tasks. So the 1.0 is available, 1.0 Pro model is available, the 1.5 is also available. So and we have the Nano, which is also like the most efficient model, because this is really built for on-device tasks like your Android AI core. So they integrate the Nano model, and they typically learn from your usage of your phone. They typically learn from that, and that's why they are like the most efficient, because they are like edge usage of Gemini. So they are more edge usage. So they are on devices that we carry around. So and the Gemma model is also built of Gemini, and it's one of the best models. So for large performances, it's also built for modality. So there are various Gemma open models that developers can tap in from and build off them. But the focus today is not on Gemma; it's on the underlying infrastructure, which is really Gemini. So looking at the Gemini ecosystem, we have the Gemini models, and people consume the Gemini models in different ways. So for consumers, for low-code users, they typically consume Gemini from their app, from their website. They can consume Gemini in Google Workspace by integration with BuildWithAI. They can consume Gemini in Google Cloud sometimes with implementation with also BuildWithAI in some tools. So for developers also, you can consume Gemini with Gemini API. We can use the AI Studio, the AI. So these are some of the various ways we can consume the Gemini model. And finally, for businesses, so under the business and enterprise, there's also Gemini for Workspace, Gemini for Google Cloud, Gemini for Vertex AI. If you have an enterprise account, you have a business account, or you just have a GCP account, you can easily also work with Gemini using the business and enterprise model. The most common one for everyone, which is really the consumer type. But we are mostly going to speak about the one for developers, which is using the Gemini API. And would also, more often than not, talk about using AI Studio and how people can also like access AI Studio to solve their different needs. So we have various usage patterns for Gemini. We have various usage patterns, and in this talk, I would only cover 4 or 5 of them, and after that we'll just do like an hands-on demonstration of Gemini before we call it a day. So looking at the usage pattern, we have some. So we have more than this, but these are the ones that I would majorly be concerned about in this talk. We have the basic prompting, code generation, search retrieval and information synthesis. We have the image understanding, and we have the responsible AI. So let's dive in to basic prompting. So what we mean prompting, so the best place to start with Gemini is just to start with text prompt. Give Gemini's text prompts and see its responses, see how we can help you solve your problem using text prompt. So text prompt is also pretty much similar to code generation, because when you're also going to generate the code, you're also more often than not initiating a text prompt to the Gemini model. So looking at it, so if you go to aistudio.google.com and you would tell Gemini to write a poem about black magic, so you can give a response like this. So the model is able to give you a poem with many verses, rhyming with each line rhyming the other line, or each line giving a rhyme with the other line. So there are like multiple examples that you can give. These examples probably go on and on. So it's able to give more than a 4-liner. So this like it makes it a nice example, but in practice, you would more often than not give it a better prompt. So let's say you want to give it a short tip. You want to generate a short tip about JavaScript, and you also like add a constraint or like add a guidance to the Gemini model that, oh, good tips, what you really mean by good tips, they are short and they can contain a code example showing the tips. So this prompt, it's going to give a better result than just using generate a short tip about JavaScript. So the basic instruction prompts that you would also give it, you can also offer it some extra guidance, and that can influence the kind of response that the Gemini model is going to give. So something like this, and you can see that this prompt is pretty clear. It looks like what the user wants. It gave the tip, it gave an example of the implementation. So these are like these are some of the ways whereby you can use Gemini. So you can also tell it to add examples. So you can also give it examples, and you'd ask it to complete it. So in this prompt way, we are like saying that, oh, this is the kind of something that I want. I want a topic to be. So let's say we are focusing on the length and the const variable. Then you'd put a tip that you prefer using the length and const to initialize variable instead of just normal var. So using that, Gemini model is going to learn from your instruction. It's not going to use var in the code snippet that is going to return from you. So these are various ways. And the more you like model it, the more you customize it to the response that you're looking for, the more it's able to deliver something that is more tailored to the response that you want. And there is also another way of using Gemini, which is the structured prompts. So the example of the structured prompts, the best example that I'm just going to use is something like, I'm going to use basic pure English. So let's say we have an input prompt, we have an output prompt. So, and the input prompt consists of some bad grammars, while the output prompts consist of the corrected versions of those sentences, or the corrected version of those grammars. So if you do it in a structured format like that, and you just pass it to the Gemini model, then you now input a bad grammar. So learning from the series of the bad and good grammar that you've inputted into the structured prompt, it's able to generate a response that it's able to just correct the new incoming grammar at that particular time using the pattern that you've used previously when you were using the structured prompt. So that's it's also a very interesting way to explore the Gemini model through the AI Studio. And you can also use it. You can also talk to the Gemini using codes. So something like you're passing your questions in a code format. Write the first paragraph of a story about the magic backpack. So Gemini is able to respond to your question. Is able to respond to that particular prompt in a codified. It's going to respond to that particular prompt that you've used in a codified format. So there's also implementation of chat interface that it can help to converse with you. So if you're making a API call, you will need to manage the SDKs by yourself, but it's just able to respond to your question. There's also a chat prompt. So there's a free form prompt, there's a structured prompt, and there's a chat prompt. So those are the three prompts that are available at the moment. And you can explore any of them depending on the use case that you want to at that particular time. And that would influence it also influence the kind of response you get and how best Gemini serves you in that particular scenario. So this is just an overview of how the Gemini sees content request and how we respond to content request. So when the Gemini is generating a content request, so these are like the things that happen in the background. So the content from the user is passed. There's also the content from the model, and the user content is also taken in as a text format. And there are various tools that are configured depending on the user. Some of them are just generic. Some of them, a user can specify maybe the temperature of the model, which will really determine how much of a different response that the model will give, how much of variation that the model can give to your responses. So the lower the temperature, so the more stable it is. So when you make the temperature too high, it gets to just give diverse responses. You can set the safety settings for your model. Maybe you don't want explicit content to come back as feedback. You don't want harmful content. You don't want dangerous content. So all this can also be toggled under the advanced setting in the AI studio. And depending on the kind of exposure you want the responses to give, you can also set that. So then the last one is the generation config, which I've briefly talked about it, which is the temperature, the top P, the top K, and how you'd set the sequence of the output tokens. I'm going to share a link to where we can just read more about this along the line. So, and when it's generating a responses, so these are like all the things that it also considers. So the candidate content, which are like the text that we gave in the previous part. So there can be a reason why the model stopped generating. You can also set if the finish reason is present, and the safety responses, the safety probability of the response, or the safety rating of the response. And all these can also be used as a feedback to the Gemini, or a feedback and giving back the prompts that we have. So here are just some last minute summary of prompting. We are moving away from prompting soon. So prompting has like a whole lot of depth and nuance into it. So Google put out some guidelines that can help us on how to generate the best prompts for our website. And there are things that you can also consider. I'm just going to drop the link in the chat section. So for some of us who want to take a look at it. Yeah, so this is what I mean. So you can go over that. It contains like some of the prompting designs that you can use provided by Google that can influence what you are doing. So examples, if you need Gemini to perform multiple tasks, you might find that it works better when you break those prompts into smaller atomic steps that are now like joined together. So let's say I want it to give me a complex SQL query. I can give Gemini a context into what I'm trying to do, an high-level overview of my column names. I can also tell him the kind of text or the kind of data types that those columns are. So all these things will help Gemini influence the kind of response that it gives, so that it's taking an integer as an integer and it's taking a string as a string. So Gemini is able to automatically do that for you, and it more often than not gives a correct response. It more often than not give a correct assumptions, but there are some edge cases whereby maybe it's a string and it's taking it as an integer. Maybe the text is not very much descriptive for it to see it as an integer. So all these things can happen. So the more often than not, break your prompt into smaller atomic steps that are not chained together, can help Gemini give you a better response. So when you also add context, it becomes more helpful. So the model is able to remember some facts that you've given it and work better to give all the information that they need to answer that particular questions. And when you set the generation parameters like the temperature, the top K, the top P, so all these things can guide how they affect your model. If you take a look at the link that I shared, you'd see a more thorough explanation on how you can do this more often than not. So let's say I want to summarize the text. I can just say summarize this text, and I input the text. So Gemini is free to just give a summary on what it feels is the best way to summarize it. But for a separate user who is saying summarize this text into 2 sentences, Gemini knows that, oh, this person wants the summary in just 2 sentences, and it can give responses tailored to that. Another person can come in and say, oh, summarize this text as a bullet point of key information. And Gemini is also able to give the response along that particular line. So that's pretty much about prompting. Let's go to the next usage scenario for this, which is, so I'm just going to be doing a brief explanation of all the usage patterns I'm covering here, because this is really an introductory section. You can go to the Google Developer Community line and you'd see some more tailored events into various use cases, whereby the speaker may do a technical deep dive into the usage case that is handling at a particular point in time. So for code generation, what do we have to say about code generation? So we all know that on top of text generation, like I mentioned before, on top of basic prompting is code generation. They are typically similar. And the concepts are also pretty the same, whereby you can request a code or script as an output. So more often than not, you can say generate a code based on the user prompt. You can convert human language request to machine request. You can do a rapid tool building. So all these things are some of the ways whereby Gemini can generate code for us. You can also generate data, whereby we can ask the model to let's say generates a sample of US states and their population. So you can generate that. You can even go further and maybe say you want to go by maybe popular cities in different states. You can also do that. So it's able to generate for us that you can use more often than not for your more often than not maybe for building your model or for just testing out some things in your model. So, of course, when you are like consuming all these responses, make sure that you're consuming them in a responsible format, and you should also be careful because some of the they should not necessarily be you should not necessarily take those data generation as factual responses. Yeah, so something like generate a table that has all the countries in the world listed alphabetically, and their capitals and the continent that they belong to. So Gemini is able to respond to this, and it will probably give correct information in this scenario. When you are asking some informations that may not be saying, maybe generate a random data of the population of each of the persons in a particular state. So that may not be very much factual. The response may not be very much factual, but to give you an high level overview of what you could expect of a response. So some examples: generate data, generate an SQL query. So if you are typically not using large language models to better your experience as a developer, you're probably doing it the wrong way. So the AI models are sophisticated enough that they can help simplify your work, they can help fasten your work. For those of us who have used maybe the GitHub Copilot before, you would attest to this, that the large language models can really help us in generating code. It helps us in doing some basic tasks that we are just doing if you understand the context, and it helps to make code generation. It helps to make writing code more easier. There are also some different prompts that can help in code generation, and Gemini is able to respond to it. And yeah, so it can simulate the executions. So these are just a few of the things that Gemini can also help under code generation. So it can also help as a peer programmer. It can help us as a peer programmer, whereby let's say you are doing something, you're not sure of the next thing. The Gemini model is able to maybe even auto-complete it for you if it's integrated to what you're doing at that part, if it's integrated to the ID that you're using at that particular time. Or you can just copy your code, paste it on AI Studio or on Gemini, and tell it to help you out. It can help you document your code. It can help you add comments to your code. It can help you even write some unit testing. But like I've always said, so when you're using all this code, you use it with caution, because if you are not someone who do not understand what you're doing in the basic way, so it may end up giving up some slightly wrong answers. But if you are someone who is already comfortable with what you're doing and you just need it for assistance, you can easily pinpoint where it is taking the context in a different format, and you can correct that from your end. So you can also use the API as a smart programmer, and this can be like really, really powerful. So let's say the Gemini API can be able to generate basic scripts really quickly and really, really powerful. So typically nowadays, if I want to write a Docker file to just a Docker image for some things, I'll just more often than not give a prompt in Gemini, give a prompt in AI Studio, give a prompt in ChatGPT, and it's able to write it's able to use some of the baseline image that I want, and able to return a Docker image file for me that I can just use when I'm building an image. So these are something that really, really helps, and really, really helps to make your programming really, really fast. So you can also do text generation. So there can be some subtle bugs, yeah, of course, that like may not be obvious by immediate inspection, but Gemini is able to maybe see it in your code and write a unit test for that particular function. So you can see it had some input checks and some type checks, and it's also worth in that this example that I just used there is very basic and it's a vague prompt. But in when you are like using it for your structured for something that's customized to what you are doing, you should be careful of how you are using it and how you're also consuming the responses. So going to the next usage, which is search and information sentences. And under that, it's a common question that when starting with LLM, how do I bring my own data? So let's say you're asking it questions about internal knowledge base or building a chatbot from your website. So we know that all models, they have a cutoff date. So there's not model that works like in real time more often than not. So they have a cutoff date of information from maybe the internet. And that's why it's a good strategy to sometimes specify the URL that you want the model to respond based on, if you are sure of the URL that you are just using as a reference. So all models typically have a cutoff date and they were trained at a specific point in time and cannot know about anything that typically happened after. So because of this, it is they are limited in their ability, and they're also limited in their ability to produce facts. And ultimately, some things that you want to ask may not be public information or may not be something that the model know at that particular time. So the best way to deal with this is simply to supply much relevant information as we can to make the model understand our request and to make the model able to respond to our request in the best format. And that's really where the beauty of the search and IR sentences comes in. So you can use the prompt context window. So the simplest way to supply contextual information is just to put it in the prompt. So some platform can call it stuff prompt, as we just stuff the information into the prompt. So let's say, oh, I want you to summarize what is happening, and you put a URL to a particular news source. So it's only going to summarize what is happening in that particular URL at that particular time. So that's more often than not what they call stuff prompting. So it's easy to implement. You're not writing any extra code. You're just doing a better ask from the Gemini model or from the AI model, and it's able to respond to that. So yes, something using a codified format whereby we are talking to the Gemini Pro model, and we are passing in a document. So this is a document we wanted to read from, and we wanted to explain how deep sea life survives. So it's going to, and you're also giving it a constraint here. So in the prompt, you're giving it a constraint that please answer based on the following document. So it's only going to answer based on this particular document that you've passed into it at that particular time. So the Gemini 1.0 Pro is limited to 30K tokens. That means it can take as much as 30K inputs, 30K characters, or 30K word. I'm not sure about that particular metric, but it's able to take a whole lot of text and give responses on that. And the Gemini 1.5 model, the limit is 1 million tokens, so you can handle much bigger problem. So what it typically means is that you can typically like copy a whole textbook into it, or you can typically like pass a whole textbook into it and ask it questions based on that textbook. So the tokens that you can accept they are really, really massive. It can help us in responding to our various questions. Yeah, so going forward, we have the different Gemini model versions, the Gemini 1.0 Pro, like 32K tokens, the GPT-4 Turbo can take up to 128K token, the Cloud 8 2.1 can take 200 tokens, and the Gemini 1.5 Pro can take up to 1 billion token. So you can pass a 1 hour worth of video to it. You can pass up to 11 hours worth of audio to it. You can pass up to 30K lines of code, and you can pass up to like greater than 700K text of words. So it's really the words. So it's words. So you can accept up to 700K words at a go, or even more than that. Yeah, so that's how powerful the Gemini 1.5 Pro model is. And so this is something that Jeff Dean did, which just really showed the power of Gemini Pro on effective retrieval with giant context. So it kind of like passed, let's say maybe let's say a textbook. So the best way to just understand a textbook, and it's asking the Gemini model to recall the information based on the textbook that it has passed to it. And this is how it's really performed for the video, for audio, and for the text. So which is really really impressive. So you can also use the prompts context window when you are using the search and AI token. So just a summary, you should remember that the model takes in your input as tokens, and the more you specify, the more you input can also influence the kind of response that it gives. So you should also take note of the context to be more flexible rather than just some retrieval augmented generation. So make sure that your contexts are flexible rather than just using some RAG generation model. And the more input context, it also means the higher latency. So the more bogus text you put, the more latency in going through all the text and returning your feedback based on the text. So that's about that. Going to the next usage pattern that we are considering in this talk, which is image understanding. So this is more focused on textual capabilities of Gemini so far, but it kind of like has a sidestepped one of the most powerful image feature understanding among all AI models currently. So the Gemini is able to look at the image prompt that you give it, and able to suggest responses based on its own perception of the image, or based on maybe its own perception of just the emojis that you're passing into that particular prompt that you're giving at a particular time. So something like this. So if you pass something like this to the Gemini model and you ask it to guess the name of the movie, so the Gemini model is able to guess it based on its thought at that particular time and say, oh, this is Charlie and the Chocolate Factory movie. So this is because it could see something like a chocolate, and it could see something like an emoji which represent a factory, or an interaction which represented a factory and a chocolate. That's why it could influence that response that is given. So something like this also, we can anybody to guess what the Gemini model is going to respond for something like this, just to make it a little bit more interactive. We can guess. Yeah, so I can see someone saying Home Alone. Yeah, something like that. Any other guess? So I feel you may be correct, but let's see what Gemini gives. Yeah, yeah, so Gemini calls it Home Alone, and he also explained the rationale behind. He explained the rationale behind his decision. So the first emoji is the house, which could represent when Kelvin was left alone in the home. There's also the scared face when Kelvin realized I was the only one at home. And the last part, which is the emoji of a Christmas tree, which represents that which represent the Christmas season in which the movie is really set about. So something like that. You can also guess the name of this book. Anybody to guess the name of this book? Yeah, so I'm just going to wait for like 30 seconds before we just show the answers. Yeah, that's a little harder one. Yeah, so but if you can take a look at the emoji, take a look at the picture, the silent lake. So let's see. Well, take note that it's a book. So let's see the response. Yeah, so let's see Gemini response. Oh, Gemini said the secret garden. So more often than not, but if you ask it to explain the rationale about this, you can see the emoji showing a short mouth, which can depict that you're keeping a secret, and there's also a garden part. So it may not be correct. It may not be, yeah, like, and it may also be correct. But this is just like the rationale that I use to decide the name of the book. And something like this also guess the name of the movie, and it can give a response that the answer is the space. How do you say? Because you can see the space. You can see the emoji representing someone in space, something looking like a monkey face, and something looking like a galaxy. So it can use that in giving out the responses that's given at a particular time. Yeah, so I can see your hand raised. Please let's just keep all questions to after we are done, or you can just use the chat prompt, and maybe someone also from the attendees can also join us. So they are pretty much maybe some Google developer experts on the call that they can also respond to your questions that you have. Yeah, so that's about that. Yeah, so let's keep going. It's also able, you can also pass an image. So there are some of the things that we used to do during maybe when we were in school, or sometimes that you just do like a pictogram of different things and depict it as a response. So if you pass something like that to Gemini, it's able to take a look at the image and understand what the image is talking about. We talked about multimodality, that you can understand text, they can understand audio, they can understand videos, they can understand videos, they can understand audios, they can understand image and chat. So all these are part of the multimodality model of Gemini, or the multimodality compliance of Gemini. So it's able to understand it, and it can give responses based on that. So Gemini, it's really here to help solve our problems across the AI space, and it can give answers depending on what we are doing at that particular time. So that's some part of image understanding. So as you all can see, Gemini is capable of understanding the content of image, and they are like positional parts of the model input. So they can also be interleaved to text prompts as the subject of the question. So you can ask, what is this, and put the image after that, or as a context for some larger textual instructions. So you can just pass some image and say, oh, these photos and text represent a day of activities. Please summarize the event. So let's say I put an emoji of someone who's dancing, I put an emoji of someone who was reading, put an emoji of someone who was maybe playing football. So, and you would ask it a question that, oh, please summarize the activities going on here, looking at these images. And it's able to summarize it based on what you've passed at a particular time. So you can use the multimodal capability in this particular format to get the best out of it. So so let's say we want to use the vision model of Gemini in a codified format. So you can also use it in a similar way, whereby the API is the same as we use for text interaction. So similar API. So you just need to use the model that has vision capability. So the Gemini Pro Vision pass that. So if you are using a long one, let's say you're not using the vision model, so it may typically just give a wrong response, or you may typically not understand very much what you are trying to do. But if you pass the particular kind of model that is similar to what you want to do at that particular time, it can influence the kind of response that you would get. So something like this, we are passing an image to it, and the first text will just be basic, and we'll just load the image. So the Gemini model is able to generate responses based on the email that we pass. So if you look at the previous code, so I passed them, you pass the image to the Gemini model, and you now ask a prompt that, what instrument is this? What kind of music would use this? So it's able to understand that, oh, this looks like a pipe organ. It's a musical instrument that produces sound by driving pressured air through the pipes. So the Gemini model is able to understand typically what we are asking in our image, and give responses based on that. So a singleton in the generate context and content request, it takes like a sequence of input chunks, and each chunks is seen as a single mode or a mini type, and you can use it to interleave the text and the images in your request. So it's more of like it's going to over like maybe each pixel of those particular image, and understand what the image is all about, and influence the kind of response that it gives at that particular time. So also RAG. So there's no example here that we can also use RAG. So you can also inculcate RAG in the image understanding conditioning that you are giving it at that particular time. So something like this also, if you pass an image to your Gemini, and you ask it to more of like just looking at the prompt that we used there. So like write a character statistic sheet based on this character. So it's able to look at the image that you passed into it, and say, and suggest a name for it, suggest a name, suggest a race, suggest a class, and suggest a different other class for that particular image, which is really the beauty of Gemini. So a fun way to express this can just be using image as a creative source. So you can see this example uses like an hand drawing of a character as an inspiration for generating the characters of that particular image there. So it can also like helps in more often than not what we call optical character recognition or just text extractions. So you can demonstrate the structured data extraction from Gemini, whereby you just want it to extract the text from the image that you're passing to it. So take note that you should be using the model that is more built around vision when you want it to understand images. So something like that. You can also ask it to convert something to JSON from images, and is also able to respond to that. Yeah, so here are just pretty ways where you can use that using the freeform prompt or the chat prompt, or even using the structured prompt format. So we can also take this one step further by also using a codified version. So something like using a schema definition, using a Python Pydantic library to just see some of the information from that particular image that you're sending at that particular time, or to just generate more often than not a structured text from what you are doing. So the Gemini model is also able to read through what you're passing in through it, and then give responses that are tailored to it. So something like it's downloaded the image and you process it. So after it downloaded the image, you provide a prompt that is straightforward, and you can also add guidance that are necessary in that prompt, and you can load up everything into the Llama Index Gemini model, and it's able to just see what's happening at that particular time. So you can also do the same thing for something like this, whereby you build a Pydantic parser for the schema that we are defining, then you bundle up the image and prompt to the parser. So more often than not, something like it takes the multimodal LLM completion program into it. And after that, it can run the program that we use to get the object back for us. So all this may be a little bit complex for some of us who are not like very much technical people, but the high level overview of what we are saying is that when you put in images, you can generate information based on that image that you're putting, and it's also able to take all those images in different formats. You can use it as a normal prompting use case, or a normal code generation, or just using it, or just even exploring the capabilities of the multimodal of the multimodal compliance of it. So that's about that, and we are moving close to all the usage pattern that we are covering. So the next one is the responsible AI part, and the responsible AI part is the really interesting part. And so when we are using AI models, Gemini, or any other AI models, or any other large language models, we should inculcate responsibility in our usage. We should inculcate safety settings in our usage. So we should make sure that these models are really powerful, but we also make sure that we can help in determining the kind of response that we get, like setting the safety settings of your model, like knowing how you are using the responses of the model, like when you're also, let's say when you're using Gemini for documenting your code, you don't want to pass in your secret keys to the Gemini model. You don't want to pass in your password parameters that you're using in your code, though it's even a bad strategy to input to save password parameters in your code. So if you don't want to be using all those things in the code that you're exposing to Gemini. So all your PII information, make sure you take them back. And when you even use Gemini to generate information, make sure that you are using them in a responsible format. So here are some things that the Gemini model comes with inbuilt. So it's able to show some built-in safety filters on certain content. They are like enabled by default. So like, let's say like the explicit content, dangerous content, the temperature of the model. So under the advanced settings from AI Studio, you can toggle this. You can reduce the severity of the responses of the model under all these various headings. So yeah, you can change them, but it is a good advice to use them with caution, and make sure that you only perform comprehensive evaluation while you are using these models, so that if you are, let's say you are using Gemini to generate content about maybe a science fiction, so it's possible that there are some dangerous content in a science fiction, and you want the model to do very well in generating those content. So in that particular case, you may want to um reduce the severity of limiting the dangerous content that is going to show at that particular time. So just depending on your use cases, you can choose the severity that works best for you. And that's the last usage that we are really talking about here. And all these things that we've talked about, you can explore them under the ai.google.dev.